In this video, we'll review the AAPM TG270-sQC test pattern, one of the test patterns available in the IQC version 2.2 software of the PACS Display software suite. The TG270-sQC test pattern is to be used for simple QC checks by regular users, technologists, and even physicists. It contains many different regions, and we'll review each of them individually on the following slides. Let's start with the top region of luminance squares and small test patches. The 18 squares at the top of the test pattern are equally spaced throughout the grayscale. For an 8-bit display, this means they'll be spaced every 15 gray levels. The 8-bit display value is displayed in text at the top of each box. Each box contains 2 bar patterns, which should always be displayed at 6 pixels per line pair, regardless of the size of the pattern. The bar pattern in the upper left-hand corner of each square is 5 gray levels below the background of that square. Meanwhile, the bar pattern in the lower right-hand corner of each square is 5 gray levels above. You'll note that at the extremes, at 0 and 255, the gray level cannot be lower than 0 or greater than 255. In those cases, a +3 and -3 gray level patch are shown in the upper left and lower right-hand corners as displayed here. In order to use this region of the test pattern, you should scan with your eye in a raster pattern from 0 to 255, following the lines shown here. This allows you to verify that the visibility of the bar patterns in the corners of the patches is roughly consistent throughout the entire luminance response. If the visibility of the patches changes or is not visible at certain levels, it may indicate that the display is not set up to follow the DICOM GSDF. Note that the +3 and -3 patches in the extreme corners of the 0 and 255 patches may not be visible on all displays. Next, let's review the luminance patches in the central lower region of the pattern. This region of the pattern contains luminance patches for uniformity and min-max luminance measurements. You can also zoom and pan these patches to make uniformity measurements around the display. If you don't have a photometer, you can use zoom and panning in order to make a qualitative assessment of the uniformity. Next, let's look at the lower right region of the pattern, which contains a high contrast, high frequency bar pattern. This region of the pattern is used for spatial resolution verification. At 100% magnification, the user should verify that you can see 1 pixel row on and 1 pixel row off in both directions of the pattern. You can use either a loupe or a magnifying glass for small pixel pitches if you're unable to visually verify it with the naked eye. If your graphics card and display are not set up to display at the native resolution of the display, you'll have an interference pattern. You will not have a clean black and white line pattern as shown here. Lastly, let's look at the grayscale ramp along the bottom of this pattern. There's a continuous grayscale ramp which can be used to evaluate all gray levels. You can visually assess this for grayscale errors. Here are several examples of the types of things you may see when looking at this ramp. Here you can see a clean representation of the ramp with no visual discontinuities or other errors. Here you can see a miscalibrated gray level which shows up as a clean and distinct bar on this pattern. If this is visible, you may want to recalibrate your display to verify that the luminance response function is smooth from black to white. Lastly, if there's a bit depth configuration error where your graphics card is not set up to run at the proper bit depth, you may have an error like this, where there are obvious discontinuities throughout the entire grayscale.